Okay, so this is Zachary Azeta, and I'm Wu-chang Feng. Uh, we are from Portland. So this is about us. I'm a professor at Portland State University in the Department of Computer Science. Zach is a senior at Grant High School, but it turns out he's the brains of the operation, and I'm just the marketing team. This is what he did last summer, and it was really cool when he did it last summer, but like it's at a whole different level now. If you've seen like last week, what people are doing with this kind of automatic penetration testing and exploitation. So just realize that this was like early last summer. It was kind of like, oh yeah, this is kind of cool. Let's do a workshop on it. And now it's like, well, this is common practice now. Resources and setup. I sent an email with the slides, but there's a repository of other talks and content at that bit.ly link that was in the slides. It does assume minimal prior experience with both generative AI applications, agents and agentic applications, and MCP. So I'm going to try and teach this at a kind of a more basic level. So this is why, if you are already working with it and you're already familiar with this kind of thing, you go straight to the labs and then just ignore the talking, which is, yeah, I won't take it personally. It happens all the time in my classes. Students are not paying attention. I'm like, okay, I'm good with that. If you want more after the workshop, so this is now an exercise in one of my classes, and this is CS 475, Generative Security Application Engineering is the course. You can, ask ChatGPT for it or Google. And then all of the labs for the course, not just PentestMCP, but all of the labs are at that URL, which is, I pulled out a subset of them and put them in this workshop, but you could do the whole gamut and you can see what the discipline has come to or is moving towards there. Okay, so this started out as a 2-hour workshop and they gave us 4 hours. And so I figured, yeah, I'm gonna take 30 minutes of that extra 2 hours and give you a kind of a background of just why we created this generative security and application engineering course and why I think it's probably one of the most important courses a student in computer science and security should take, because this is where everything is moving. So I'm going to talk about the design of this class and what are the principles that go behind it. And then I'm going to talk about agents. I'm going to introduce what agents are and the model context protocol, which is really superpowering agentic AI. And then you're going to do a lab that is, you're basically going to use a SQLite 3 MCP server, and you're going to use that to do natural language querying of a database. And then you'll see how insecure MCP servers can be because they're programmed by people like me who don't have, I have a little bit of security background, but there's a lot of people creating MCP servers that have no idea what an adversary would do to them. And so we've got a bunch of insecure MCP servers. And so this little exercise will show you how you have to go about securing the tools that you allow agents to have access to. It's just a simple exercise. And then we're going to do the good stuff, the PentestMCP work, which is basically automatic exploitation. And we have a lab that I used to have. I still have my web and cloud security class do. Like we have a lab that says this is how you use Metasploit to automatically compromise the Equifax struts service, and then we're going to appoint an agent to it now. And we're like, well, like we don't need a human to do that anymore. And that's your lab. That's kind of like the keystone lab of this workshop. And then we have other penetration testing sort of tools and agents. They're not as cool as PentestMCP. But it just gives you a range of other kinds of ways you can build agents and tools to compose them to go and compromise a target. That would be the rest of the workshop. So there's a choose your own adventure at the end of this. So if you like web hacking, there's a web hacking one. If you like scanning, there's a scanning one. If you like database exfiltration, there's a SQL map one, and that'll end the workshop. Okay. Any questions before I just jump right in? Okay, so let me talk a little bit about generative security application engineering. So I got a grant from the National Science Foundation to build a course, and then that's actually what funded Zach's internship. So I'm going to talk a little bit about the overall design of this. And just to give you some context, if you are interested in developing generative security applications, what to keep in mind. How do you think about the problems as you're trying to solve them? So the motivation is clear. Like if you look around at all the talks in this conference, it's all AI stuff, a lot of it. Like I would say 50% of it maybe. And it's for good reason, because this is actually automating things in a really meaningful way, which is going to save a lot of people a lot of time. And this is just one example of what it does. So all of these things that they have said are being better done with the help of AI. And so the goal of the project was to reimagine security education for the generative AI generation. Like we got to teach them something different. And I'm looking at the inventory of what I teach, and I'm like, oh, maybe I should stop teaching them some things, and we'll talk about what those things are, and teach them something else. This motivates the course. So I'm going to give you an outline of this course. You can go to that website and actually look at all the slides, do all the labs, and get the same experience. So this is the course that I offer. We first start with benchmarking modern models on basic tasks. So students have to be able to prompt the LLM in a way that they can get predictable and useful results out of it. There is no other way to do this except to practice, practice, practice. And you'll see, I say that it's like a love language that you're speaking to the LLM, especially when you get to agents. It's like they want to be told certain things in certain ways, otherwise they're going to give you garbage. So that's the first part. It's like all the different strategies for communicating with an LLM goes first, because that's basically the backbone of the rest of this course. So that's the first part. And then we're like, well, what are these toolkits and frameworks that have been developed for you to quickly leverage LLMs to be able to solve problems that you care about? And so we introduce LangChain. LangChain is just one of several open source frameworks for building LLM applications, and it's portable so that you're not locked into a particular vendor when you build your application. And then we also teach them MCP now. So this is a new addition for this year because MCP took off. And that's also an interoperable way of enabling LLMs to work better. So we teach them that for basically 2 weeks. We don't got a lot, this is like a 10-week class, so I got a certain budget. So it's like 2 or 3 weeks, actually 3 weeks of LangChain agents and MCP. And then because we're security people, we got to go through all the ways you can compromise generative applications. So OWASP has their top 10 LLM vulnerabilities, like prompt injection, excessive agency, insecure tool design. And then we show them examples where it can go awry. And in fact, they are building their applications throughout this. And one of the things I do is like, I tell them, your agent, when you write your agent for this week's assignment, you have to leave in the terminal tool. You have to leave in the Python REPL, because the next week, I'm going to have you convince your agent to do something really bad. And then you're going to realize we are in trouble. Like, then we realize that if you know AI and you know security and AI, you've got a job for the next couple decades, I think. You have job security, which is what a lot of our students are really anxious about. They're like, AI is going to replace me. But I think AI security, because there's so much insecure stuff out there right now, is like, okay, at least for, I don't want to say 20 years, but at least 10, I think we're going to be grappling with this problem. Okay, and then we finally get to, let's build applications to solve cybersecurity problems automatically. And so we have a bunch of code examples where they run and they do a code summarization task. They do a code analysis and reverse engineering task with the help of LLMs. They do vulnerability discovery and exploitation. And this is where the PentestMCP lab runs now. They do code and, so they do the vibe coding sort of week, where if you want to just use natural language to implement your security application, you get practice doing that. Prompting sort of the, like when you get good at prompting, then you can do in one prompt, you can build a security application. I have them do 5-minute screencasts. So there's a 5-minute hackathon exercise I have them do. You do a screencast, you give me the prompts, you show how most of them are using Claude Code. But some people are using Gemini and some people are using Codex to do that. And then they practice code generation and command and configuration generation as well, because those are also part of securing a backend, like being able to run the commands to do the checks and to be able to create configurations, accurate and secure configurations of computing infrastructure that you would want to secure. And then the last week is threat intelligence and social engineering tasks, automating those with the help of LLMs and agents. So every week they are taking these examples that give them an idea of how to do this, and then I have them write applications of their own. And we'll talk about why I force them to do this. Whatever they want, it just has to be under these umbrellas. So they just attempt to write these, not only applications to do these tasks, but secure ones. Like if you're not prompting the LLM for security features that you want to build into whatever it does, we're all in trouble. So at least the students I'm producing know to prompt, because if you don't ask for security, you're not getting it from an LLM in terms of code production. So you have to basically have an adversarial mindset when you are building LLM applications in this day and age. Okay, so I've gotten some adoptions. There's some folks who are taking this on. And then this curriculum and all the exercises and all the slides and the videos, that's all public. And there are some folks who are adopting it. So I next want to talk about some of the lessons that we learned. So this is like the third year of this course. Some of the lessons that we learned offering this course. The first one is that change matters. Like every time I offer this course, I have to redo the whole thing almost. Because the models change, the frameworks change. These models, they get introduced in January and they're deprecated by December. And you're like, and then the exercises that you use, you're like, oh, I have to change a whole bunch of stuff because it just moved. So that's a problem. So you get instant bit rot on all your exercises. So this is a sand mandala. This is what Tibetan monks or Buddhist monks will do. Build this thing for a week, and at the end of the week, just destroy it. This is what I feel like with developing curriculum in the generative AI age, because security is a moving target and generative AI is more of a moving target. You put the two things together and you're like, wow, like I just offer one class and then all of a sudden I have to offer, like it's obsolete the next time I offer it. So that's one thing. This is why I crowdsource my curriculum development, because, you know, what is that term? Many eyes makes all bugs shallow. That's the Linus Torvalds thing. So when you go and you do your PentestMCP lab, you're going through this code lab format, and if you see this report a mistake, I have my students like do this. It's like, if you find a problem, stuff doesn't work anymore, you click on this report a mistake, and it points you to the Google Doc that generated that thing. And then they can make the edit in that Google Doc, and I can just republish. So if you like anything you see on the Code Lab site, you just go get the Google Doc, download it, and adapt it to the way you want it, because that's the only way you can get up-to-date stuff. You have to like take something that someone else has done and update it very easily. So this is what some of the faculty members that I've been working with, they just copy the Code Lab and then get rid of all the stuff that they don't want, and then update the stuff that they do want. So that is there for you in case you want to teach generative security. So that's a problem. We have a huge shortage in people who want to teach generative security. So if you want to like fill that void, you're welcome to take all of these code labs and go offer your own course on generative security. I'm happy if you do that. If you do that, let me know, because I can help you with this as well. Okay, the next lesson that we learned, there's 6 of these. The next one is that portability really matters. There are a whole bunch of models, and they're trained with a whole bunch of different data sets, and they are tuned for a whole bunch of different tasks. The models that are implemented, they have variable context size. They have variable performance on the tasks you want that particular model to do. And they have a varying sort of cost structure. Some models will just charge you an arm and a leg, and you're willing to pay it if it does the right thing. But you shouldn't be charged an arm and a leg if it can't do the thing that you want it to. So this is where portability matters. This is a picture of all the different models from 3 years ago. You're like, that's 3 years ago. It's like, wait, like you can't even visualize it in a plot, and this is all around the edges. This is where portability matters when you are building your application. And this is why we're using LangChain. LangChain, I view this as a portable layer, an operating system layer for the LLM model. So you want something that does this. So you have a little, this is your application, and then these are the models on the left. And you want your model to just be seamlessly able to take whichever, or your application to be able to seamlessly switch over to any model that it wants. And you'll see this in the code in the repository. There's basically 2 lines of code that you just have to comment out and to switch from model to model. And that's how we do this lab. Okay, so just to give you an example, you're usually choosing a model based on what your application is being asked to do. And you have to find the right model for your task. So if you have a code generation task, which model would you choose? Audience, answer. Codex and Claude. Yeah, I'm thinking a lot of people, so Codex is too new. The new version is too new. But almost like, so I give this vibe coding assignment I give my students. I teach them Cursor and GitHub Copilot. I don't tell them anything about Claude because they have to pay for that. Like I can get the other stuff for free for them, and I want the course to be free. When I offer it to students, it's like half of them are using Claude Code. They are paying the subscription that I'm too cheap to pay for myself. They are paying the 20, at least I think the free tier is, or the lowest tier is 20 a month. They're actually paying that to do this. So yeah, Claude, like if you can get a student to like cough up money to actually use it, you're like, yeah, it's probably a good thing. What about large context windows and multilingual processing? Gemini, yeah. Because Google intentionally, they have the best inferencing sort of cost structure because they're using ASICs, they're using these TPUs. So they can do these enormous context windows super cheap. And so you're like, yeah, if I'm too lazy to do context engineering, yeah, I'll just dump the encyclopedia at Google and say, give me an answer. And it's cheap. So yeah, and then they do the multilingual stuff really well. And they've been doing that for a long time because they have the Google Translate stuff. So they can leverage that very easily. And then reasoning, and this is not the case so much anymore, but reasoning, OpenAI, these slides were actually, the first version of this was like last year. And with the Strawberry and the sort of the reasoning engines and the ability to tune the reasoning budget of your model, it was like, okay, OpenAI and ChatGPT definitely have the best reasoning models, but I would say now Claude is also at that level. It's getting some nods. And you'll see that the PentestMCP agent works super well with Claude, works pretty good with GPT-4.1, doesn't work at all with Gemini. Or not Gemini 2. Gemini 3. Might be. It depended. Okay, so your mileage may vary. And that's one of the things I tell students. It's like, yeah, I have no idea if the lab in this code lab is actually going to work for you. Like, who knows? That's basically this quarter, so just last week, students were complaining that Gemini quit on them. And it's like, oh no, it's like, just show me the screenshot of Gemini quitting on you. It's just because like during the day, Gemini is getting hammered. And so if you're doing your lab work during the day, you're not going to get any good results. And so students now realize they have to do it overnight and they get better results because Gemini is allocating the inferencing resources to the paying customers, not the people on the cheap academic coupons. So we get the lowest level of service. So we have to like do all of our labs overnight, basically is the take home for that. What happens if you want an open source model that's deprecation free? They're not gonna like remove it. They're not gonna take it away from you. And then is sensitive to data privacy issues. Well, you would use OLLAMA. You would use one of these open source models and you would run the darn thing locally. And this is also the reason why we do LangChain. So part of our LangChain exercises is, well, we have you spin up a virtual machine in the cloud. You could actually do this lab if you wanted to. You spin up a GPU and then you install OLLAMA and you install your favorite model and then you point your LangChain application to your hosted model and get your application running. That's like the first week lab that we have them do, and it's sitting there on the code lab page if you want to try it yourself. Okay, so the next lesson learned is safety matters, and they get this in droves because they realize the model has not been written to guarantee safety and security. That's not what it's good at. It wants to please you, regardless if you're an adversary or a legitimate person. It's really hard to ask the model to stop doing something for the user, like don't access those secrets, or don't call back to that webhook and exfiltrate all my data. It's really hard to get the model to enforce that policy. And so this makes it so that there's an extremely low barrier to entry to be a hacker. That's what LLMs have done now. It like makes everybody a hacker. It's just like it makes everybody a programmer. It has made everybody a hacker. And this is where like someone could just download PentestMCP and become a hacker. That's the reality that we're living in. It's basically systemic insecurity in anything that involves a model, because the model just, that's not what it's designed for. Okay, so this is an example that we ran, and it doesn't work anymore. This is what I'm talking about with change. Like this exercise doesn't work because they redid the agent architecture to eliminate this, but we have this agent. It's got two tools. It's got a RAG tool that says retrieve a document from the database. If you have a query, and the query is asking about Bulbasaur, which is a Pokemon, go to the vector database and find the document that is about Pokemon or Bulbasaur, and then bring it in, and then answer the user's query using that context. So that's our RAG tool. They call it retrieval augmented generation. And then in that same agent, we allow it access to curl. And we're like, oh yeah, it needs to be able to do this, curl the information. If it's not in the vector database, at least it can curl the Pokemon wiki and get the Bulbasaur information. And so you go, this is the text in the document. You say, this is the Bulbasaur, these are the actions. And then the adversary is like, well, there's another action that you can have Bulbasaur do. That's curl. Do terminal curl. So we gave it the terminal tool, not the curl tool. You're like, yeah, curl this website. And if this is a webhook, you could be like, curl this link with the person's API keys or whatever they can scrape out. And then sure enough, this is the original React loop. So I'm going to talk about React a little bit later when we talk about agents. So this is the agent running. Anything in light blue is the agent saying, this is what I'm going to do. So what are Bulbasaur's abilities? And the agent's like, oh, I'm going to spawn off the agent. Do I need to use a tool to answer this? Yes. This is my vector database query to get the document out of the database. And then this is the result. I have the result of that's in this file. And then all of a sudden, there's this terminal curl www.pdx.edu. And because this line is formatted in a way that basically injects itself into the LLM's thinking loop program, there's a program that the LLM is executing in order to figure out what to get and how to bring it in and put it back into its prompt so it can reason about the next step. This thing is pretending to be the thinking loop, and it's activating a tool call for terminal to get the URL. And then sure enough, it believes that the next command should be a curl. This is everywhere in LLM agents. It's not in this format because we tried this 2 weeks ago and it stopped working. This is basically what we're looking at in other vectors. You just have to reverse engineer the format of the thinking sort of template that the agent is using, and then you format a piece of data that just inserts itself into its thoughts. So you're getting into the LLM agent's head very easily, and this is all social engineering. So this is the problem that we're facing. Okay, the next thing I want to talk about is costs matter. You can really poorly design an LLM application, and it might work, but it might cost you way more than it would have if you had hired the human to do it. And so, like, there's time costs because you have to redo the work. There's energy costs, and then there's dollars that are basically being wasted because you don't know how to, like, you haven't really thought about architecting this thing correctly. This is why my course is called application engineering, because there's a whole bunch of engineering that has to go on when you're developing these applications. Otherwise, it won't work and it will cost you a ton of money. If you have this mismatch, you're going to get terrible results and you're going to fail as a company if you are building this. So here's an example. So we run these CTFs in our lower division, and they're like binaries. And we ask students to learn how to reverse engineer binaries so they can like figure out, like when they get malicious software on their system, they figure out what it does by reverse engineering the source code. Now, you could naively say, well, I'm going to have the LLM do this. So you're like, yeah, dump this binary, just dump it right into ChatGPT and say, solve this level for me. Give me the flag that prints good job. And then this is a total waste of time, energy, and money. Less so time now, because this exercise, and again, this exercise used to fail 2 years ago, but now ChatGPT can do this one, and I would expect Claude. So I have to do a harder binary next time. But this is not what models are trained to do, unless they have tools to do something like this. So then we show them, well, you got to help the model out. You got to translate your problem into a domain that the model actually is good at. And so we show them, well, if you had a Ghidra tool in your agent, then what you would do is you would invoke Ghidra to get the C code. Now, the model has been trained with a bunch of code. That's what they do, mostly Python, but it knows pretty good C. In fact, it knew enough C to write a C compiler, apparently, with Anthropic. No, it's not a good C compiler, but it's
they copied GCC's homework, basically.
Okay.
So it's not like they wrote one from scratch.
But yeah, but the idea is this is way smaller than the compiled binary. And it's gonna be way more accurate, because this is what these models have been trained to understand. Code understanding in a domain that the model has been trained on, which is C code. Maybe if you had an LLM that was explicitly doing binary reverse engineering in x86, maybe that would be the model to choose, and then you would just dump this right in. But really what you want to do is just call the tool, get the decompiled C code, and then ask the model to solve it. And then this is like slam dunk, accurate, efficient, and super cheap. So this is what we're talking about when it comes to the engineering aspect of generative security. The next thing is skepticism matters, because everybody is reporting their highest achievements. And so we have this survivorship bias where we're like, oh, what you said worked, so I'm going to just believe that that's been the case the entire time. It's hiding all the failures. What was it, Edison? It was like, my one success hides my 99 failures. Well, people are hiding their 99 failures and just showing you the success, and then the C-suite people are buying it, and they're shoveling money at that. And so what I want to do with students is like teach them that, yeah, when the rubber hits the road, this stuff, you might not want to rely so much on it. Because this is a cognitive problem in humans that we attach to this. This is a psychological problem. So you have to calibrate with your actual experience. So I did this last week. Well, I saw this last week in a student's homework, and I had to like point it out. That's like, oh, you think this is secure? So this is a vibe coding example. You're like, oh, I need to prevent SSRF into a private network. So SSRF is that if you have a proxy and it takes a URL from you and it goes and it gets that URL on your behalf, well, there is an attack called a server-side request forgery, where it's going to ask the proxy to get something super sensitive on the private network. Now, you put that thing in the private network because you didn't want the adversary access to it, but it's sitting there and it's like, it's tricking your proxy to expose all of this stuff on your private network. And so one of the things that it'll try and do is it'll try and use your proxy to ask it about itself. So this is like the Capital One breach, where there was a vulnerable web application firewall, and then the attacker went to the metadata service that's sitting there on the virtual machine and exposing all the access tokens. And so one of the things you want to do is like, I get a URL, I got to check to see if it's localhost, because you're going to try and use your localhost connection to get all of those services, local services, that are only meant to be accessible internally on the machine itself. So this is the prompt. So they vibe coded this. It's like, yeah, I need a safe get. You need to filter this. And the LLM is going to produce me secure code, and I'm going to feel good about the whole thing. And then it gives you this code. And you're looking at this, and you're like, oh, yeah, that looks pretty good. That's plausibly good. Anyone see anything wrong with this? Like, what's wrong with this code if you look at it? Now, this is, on the surface, this is what you would teach people as being good. It's like, oh, it's got all the private networks. It's got localhost. What could go wrong? What could go wrong here?
Isn't there another one for EC2 uses where they use 169?
Oh, yeah. Okay, so that's missing. Yeah. But even if it's just, so we prompted, oh, you're right, private internal. Yep. What is that number? Yeah, that prefix isn't here. So yeah, missing that so that's a good one. I should. Yeah, you're right. That's not there. So that's not the one I'm thinking of, but that is also so good. I have to add that. I have to add that to my own. Yeah. Oh yeah, IPv6. Yeah. So they didn't even ask, and it assumed IPv. Yeah. Oh, that's another one. I got to write these things down. Oh, I'm recording this actually, so I'll just have to rewatch. Yeah. There we go. So yeah, you could just ping an integer. It's like, oh yeah, I'll just put that right into the IPv4 format. And then you could say, yeah, I'm going to ping a hex number. And then I'm going to ping a combination of octal and hex. Like, it doesn't catch any of this, but it makes you feel good, doesn't it? You're like, oh yeah, wow, look at that. Well, it's better than nothing. At least the student knew to say, I need the safe get. I need to actually make sure it's not localhost, but the implementation's wrong. And like, who's going to catch that? So hopefully this example lasts a couple more years before Claude Code says, oh no, I'm going to do it the right way. And then this one, yeah, this is similar to that one. So yeah, but this is like a different prefix than 127.0. So, okay. So that's 5. The last one, and the one I really want to talk about, is this: creativity matters. So if you remember Calvin and Hobbes, that was the whole point of Calvin, was that he dreamt up of things that nobody could think of. So I actually believe, well, I think it's true that generative AI is completely removing the importance of mechanics. So when I was a kid, my mom gave me 10 cents to fill out this number grid, 1 to 100, then 101 to 200. Any of you do that, like, as kids? Maybe it's just Asian culture, but like, yeah, I was just sitting there. This is before we had printers and personal computers. So this was like, okay, I can't use automation for that. So this was like, okay, that's what we did before printers, fine. And then I got to college as an undergraduate. They're like, everything that I talked about in this quarter, you can write down in 3 sheets of notes, bring that to the exam. And this was before we had Google. So we'd be like, yeah, regurgitation, that's a skill that you need before Google. And then I got to sort of grad school and my job, and I'm like, okay, let's grind away at the Linux command line. That's definitely useful work. So all the different commands on Unix that we like to use. And then if you're a penetration tester or you're doing security, you got all these command line tools. I got TCP dump, I got nmap, I've got all these things. And this was before LLMs and before LLM agents. So this is where I'm looking at my curriculum and I'm like, yeah, do I need to teach some of this stuff anymore? And how much of it should I teach? Like, do I need you to memorize nmap flags, or should you just be able to say what you want? And that's the question that we're asking with this course. And so, you know, you take a step back and you're like, well, what is our value add going to be if all the mechanics are taken care of? And so I would argue, in a world where you can just take your ideas and turn it into a working implementation, I would argue that it's creativity and imagination. And this is why students in my class, they have to build every week. Like, and whatever comes to their imagination is what they're doing every single week. Okay, so the question is how do you foster this? So I'm going to go to a musical example. There's a music group that I kind of follow, kind of religiously. And so I look at this group, and this group they have totally mastered the foundational disciplinary knowledge. They are music geeks. So they understand the theory, all the different chords and keys and all of the sort of the transitions and the composition parts of it. They also know all the different genres. In fact, they produce songs in a lot of the different genres. So they know all the disciplinary knowledge. And then they sit there and they practice the tools of creation all the time. So, you know, started out with just guitar, drums, and keyboards like a traditional group. But then they do orchestral arrangements, and they do washboards, and they do vacuum cleaners. And so they're practicing this all the time. And then they do this jamming. Every single concert is about practicing creativity. None of their performances are the same. This is a picture of them in the Las Vegas Sphere. They played 4 straight shows and they didn't repeat a song. And I'm like, God, that's crazy. It's like I can only do 1 song at a time, and they're doing a whole perform 4 days of this. And then because it's security, you have to profit at the end of it. We have a long tradition of profiting at the end of our exploits, and so they have definitely profited. Does anyone know who this group is? No? I give stickers to my students who know. This is fish. So yeah, so the idea is like, can I make, and then I see fish and I see how good they are at producing things organically. They've mastered all of these tools, and I'm like, I need to do this for my students. So how do I do it? So if you look at these labs that I point you to, there's a whole bunch of stuff where they are learning foundational disciplinary knowledge. They are learning different things about programming languages, regular expressions, different systems like Linux, like web servers, firewalls, OAuth 2. They're looking at infrastructure stuff. So they're learning about Google Cloud, Docker containers, Kubernetes manifests, Terraform, and open API specs. And they're looking at all the different document formats, because when you're doing your RAG application, you have to know about all of them. So you have to have foundational knowledge of everything that's out there. And there's a ton out there. There's so much out there. That's why there's like 1 code lab for each one of them. There's 1 code lab on Terraform. There's 1 code lab on Kubernetes, because it's just like it's a run list. And it's got to have all of this stuff in there. So there's labs for each one of these things in that course. So that's just like the stuff. But then there's securing all this stuff. There's a whole bunch of tasks that cybersecurity people do that they have to understand and learn about. So all of the different areas of cryptography, I don't do a ton of cryptography, but like access control, vulnerabilities and exploitation, they have to learn all the different tasks. And then they also have to learn all the different tools that can perform those tasks. So then we have them look at Nmap, SQL map, nuclei, and that's why we have these PentestMCP is a perfect example of this. To basically compose all of these tools as well. So that's the first part, foundational knowledge. You got to have it. So in the age of AI, you cannot get by without the foundational knowledge. People think that we're just going to let the AI think for us, but you have to tell it what you want. And the telling it what you want is basically the thing that's needed is foundational knowledge. You have to know what you want. So the second piece is mastering the tools of creation. So this is the age of AI, so you have to know how to communicate with models effectively. This is all the prompt engineering stuff. You have to be very good at prompt engineering. You also have to be very good at sort of specifying applications in these frameworks like LangChain and MCP. You also need to be able to be proficient in generating code from LLMs. So automatic code generation also has to be part of this. So you need this if you're going to actually produce generative applications at the level that fish is producing songs and performances, is what we are arguing. Okay, so this is what we have them do. We have them practice creativity every week. So you're building a bunch of LLM applications using LangChain and MCP to solve cybersecurity problems. And then you're also using coding agents for building applications without writing a line of code. So I have the inverse cheating problem. I have, in this week, I have in 1 week, and like you're not allowed to write a line of code manually. And I have to validate that they didn't by having them do a screencast showing me that this is all prompt generated. And so students can sometimes cheat. They're like, in their prompt, they'll say, put this line of code in line 53. And I see this, I captured this, I'm like, this is hilarious. This is the new way of cheating. When you're told not to write code, and then you just tell the LLM to write that line of code, technically that's not cheating, but that's against the spirit of the assignment. Like, you should be able to specify that up front so that you don't need to prompt the patch, right? That's like the whole exercise is to get it right with the first prompt.
It's like on Notebook when it turned out that half of the AIs were just people on the AI social network.
Yeah, it's a weird reality loop that you're like, who is impersonating what? And yeah. And then I'm gonna profit is at the end. So hopefully they profit by being able to get a job in this day and age. But at least for me, this is why I offer this course. I profit intellectually because I get to see all of this stuff and I get to actually put it all into a talk. this is where I like, yeah, this course is like has rejuvenated my career at least. And I'm like more interested in security now than I was before, and generative AI. I didn't know anything about generative AI before, but this is why you would want to teach something like this to keep up with it. Because really, the thing is moving so fast that if you don't have help keeping up with it, you're gonna fall behind. And so that's where this has been super helpful for me. Okay, so that is the course. Now I'm gonna just jump in to kind of scaffold you to the exercises that we're gonna do here. So I'm gonna introduce agents and the model context protocol, which is sort of a foundational technology that I believe agents will be built upon. So I'm going to introduce that first before I talk about PentestMCP, because it'll kind of motivates why we're doing it in this way. So initial LLM applications were simple chains of functions that you would just pass through an LLM to get a result. So this is the initial way we're using ChatGPT. You send it a prompt, you invoke it as a function, and you get an answer. Or this is another chain of execution. You get a prompt, and then maybe you'll ask the RAG database or the vector database for some context to add to the prompt, and then you send it to the LLM, and then you get the answer. And so for these first generation applications, that was fine. That worked really well. But what happens if this isn't enough? If this is insufficient for your applications? So there's a lot of applications that require iteration and reasoning about the results so that it can do more complex operations. And so for that, this is where agents are there for. So this is what an agent architecture looks like. You have an agent. It's given memory. So when it goes and it does some operations, it's going to take the results of that and store it in memory because it has to track where it is in its execution. And then it's going to be given a set of tools to go and find out more information or to invoke actions to further it along in whatever its execution plan is. So that's the two pieces that they attach to the LLM that made agents possible. And then when they take a prompt from the user, the LLM is going to look at the prompt and look at the tools and then reason about how is it that I'm going to invoke tools to address this prompt. I'm going to say, what are the steps? What do I need to do to go through this? And then what I'm going to do is I'm going to take action. I'm going to take that first step and I'm going to execute it. And then I propose this action and I invoke it. So I give the LLM the ability to call a function, to call a tool is effectively it. It's going to get something back, store it in memory, and then it's going to go, the results are going to go into memory, back into that prompt, and it's going to be sent to the reasoning again. And the LLM is going to take what's there and reason about the next step. And then it's going to do this in a loop until it gets the answer. So this is the classic agentic sort of loop. I'm going to talk about the levels of agency that have been proposed. And we're going to mostly do this multi-step agent. So PentestMCP is right here in the middle. But I'm going to just do a rundown just to give you an overview of all the different agent architectures that are out there. The first one is no agency. So that is the initial generation of applications. You're just treating it as a function call. So here's an example. Write me a haiku about Bulbasaur, and I invoke the LLM as a function call. And that's typically what you would do. Here's another one. This is a chain of functions. This is one I run this for high school kids because one of the things that you're interested in is how biased is my model. Like, is it giving me reality or is it giving me something skewed? And so this is an exercise. It's gender bias and occupations. Like, what I have the program do is that it gets a story prompt that asks the LLM to generate a story about a person in a particular occupation. And then I have another prompt that says, figure out the gender of the story that got produced. And this is an example of calling a chain. And so then I say, send the occupation to this story prompt to generate the story. And then take the output, you can print it out, and then send it to the gender prompt to determine the gender. And then give me the output. What is it male, female, or other? And then I'll just do this in a loop. I'll say generate 10 stories. In this case, I have a loop that said do this 10 times and give me the result. So this is a chain. It doesn't require any reasoning. So this is one of the, and the results are surprising. I have this code in the exercises of the class, and like students are like testing all the different occupations all over the place, and you're like, oh wow, yeah, this is totally skewing reality or not. So then you can choose to rely on the results of the LLM or not based on what you have measured with your own eyes in this case. Okay, the next kind of function is a router function. So in this one, you just use the LLM to figure out, you have all of these code paths in your program, you get a prompt, and then you say, you know what, I know that the best code path for handling this prompt. This is the architecture of most modern LLM systems. Right when you type a prompt into ChatGPT, it figures out, like, where do I send this to? I have a bunch of tools, ChatGPT and Anthropic, or Claude Desktop, they have a bunch of tools, and they have this thing called a mixture of experts. So these modern LLM systems have a bunch of purpose-built systems for handling whatever you ask it. So in this case, if, for example, now, if you give it binary code, I bet you it's going to send it to the routing part where it does the disassembly first. So it might be doing that in the background already, and that's the routing function up front. Look at the prompt, look at the tools or the specialty that it's asking for, and then route it. So here's this person is asking for code production, so I'll send it to the Python path. It's asking for poetry, so I have a model trained to generate poetry down here, something that's Wikipedia, an image creator, or a legal expert. So that's the router. There's also these tool calling agents. So this is the next step towards a full-blown agency, but the next step was to allow the LLM to invoke a function call in your program. And so that's the idea. You give it a specific set of tools that it can call, of functions that it can call in your program, and then you allow it to generate the invocation and then perform the execution of that. There are a large library of tools that are built into LangChain. And this is why LangChain is this $125 million unicorn, is because they were first to market, and they have this enormous library of tools that you can just build right into your LLM agent. So in the third week of our class, I'm like, yeah, just find whatever tools you want out of the LangChain library, and then build an application on top of that. And then because it's so rich, they have a field day finding these tools that they want to put in their application, and then just building an application of their choice. So this is just a picture of some of the tools that they have. Okay, so here's an example of both a router and a tool calling agent. So there are two code execution tools that are shown here. So Riza is a company that is basically giving you an execution sandbox as a service. So if you are playing fast and loose with your agent and you're allowing it to execute unknown code, you don't want to run it on the system that the agent is running on. You want to forward that off to someone else's computer and detonate it over there. So we have like malware sandboxes like VMray that we're like, oh yeah, here's some malware, go detonate it for me. Or VirusTotal, like I don't want this malware. I don't want to analyze this malware here. Like I'll let VirusTotal do it. So the idea is the same for Riza. I got some unknown code my agent wants to know about, and I better not use the Python REPL or the JavaScript engine on my agent to execute it, because it might just rm-rf me. So this is an example. So you say, okay, I'm going to allow the agent two tools, execute Python, execute JavaScript. And I'm going to say, create the tool calling agent that is allowed to invoke both of these two. And then you get this input. User says, print hello, that's Python. And then it knows it's doing the routing. Say, that's Python. I'm going to call Riza exec Python. Or if you get console.log hello, well, that's JavaScript. I'm going to do the routing function. And I'll put this over to the Riza exec JavaScript. Okay, so that's an example. All right. So the next thing is multi-step agents. So I have tool calling, and I'm just going to add reasoning to it. So I'm going to combine tools, language models, and a reasoning in a loop. And this is where agents come in. These are the steps. The LLM gets the prompt and then generates a multi-step reasoning plan based on the user's question. And then the plan is going to include the use of tools and then the ability to to be able to identify when the answer has been found and to return that back to the user. So that's the planning. And then it's going to say, I'm going to propose the next step. Based on that plan, what do I first do? Which tool do I call? Or if I don't need a tool, I'll just generate the answer and return it, is the idea. And then I'm just going to invoke that tool. So call the database or call an API, and then observe the results. I'm going to bring the results back and update my plan. It's basically going to fill in a prompt, and it's just starting to append to the prompt, and it's going to take that and reason about it again. This is where you can poison the accumulated prompt with all of your garbage prompt injection stuff to get it to do crazy stuff, which is basically a Gemini, Claude, OpenAI. They're all dealing with this stuff because, like, yeah, if they can't identify the crazy stuff that the adversary has put into the prompt versus the legit system prompt, you're in trouble. And there's no way to delineate the two. This is like SQL injection that's unfixable because you don't have a prepared statement or a parameterized query to do this. So this is why we're all in trouble, actually. I mean, we're all in the same boat. Like, this stuff is everywhere, and we're all going to pay for this one. Yeah, but you're helpless. Yeah, you're like helpless. Like, oh, there is no patch for this. You're like, oh wow. This is why I tell students, is like, well, at least you have a job, maybe. Well, it depends on what happens when we do this. So, and this is what it looks like. Question, the agent's like, oh, I have a plan. I'm going to do an action, get the result, put it back into the plan, and then do this in a loop and send it to the output. Okay, so this is the initial one. There are better ones now out there, but this is the one I like to teach on because it kind of makes, it's how we think. Like, we don't think in parallel. Like, some of these ones are parallel execution planners. That's not how humans evolve. So like when I teach agents, I teach this because this is like, oh, yeah, you have a goal, you take the first step, you get the results, then you think about what to do next, and then you get the results. So that's typically how humans work. But now they've got all these fancier ones where like you generate the plan and you get a whole bunch of people, agents or sub-agents to execute that. That's also a way of doing an agent. But I'm going to just do the React loop because it's the easiest to teach from. And what I showed you in the previous slide is basically what it does. It basically takes an action, gets the observation, performs a thought based on the results, and then performs the next action. So it's in a loop. This is the template that it is using to bootstrap its own program. So this is the internal program of the agent that you are seeing here, and it's a natural language prompt because this prompt is going to get filled in, and after every step, it's going to be sent back to the LLM, and the LLM is going to produce the next step. So this is how the sausage is made in agent, and then you're like, yeah, this doesn't, like, I really have to make sure the LLM doesn't fall for anything is the problem. So this is what it looks like. I'm going to say use the following tools to answer the questions the best you can. I give you two tools, Wikipedia and a calculator. And the way you use the tools is by invoking it via a JSON blob. So everything in the backend is all JSON formatted and invocation. This is why all these models now have to be really good at generating accurate JSON. There's like benchmarks for this because this is how all the agent calling is done, is with JSON. So it's like, okay, you have to be able to generate a JSON blob that specifies an action that you are to perform. Now, what happens if this JSON blob is in your RAG database? Somebody is like, I know what JSON blob you're going to use to call your next tool. I'll just put that in my document and see if I can get you to execute code. That's what's gonna happen here, actually. And then this is like, okay, well, this is the savior at least. It's like the only values that should be in the action field are Wikipedia and calculator. And then you should have action input, which are the parameters of the invocation. And then you're like, this is the thinking loop. It's like, always use the following format, and this is the React style. You have the question, you have the thought, the action, and then the observation that comes back. And then over time, you're accumulating this as you make all your steps. And then the LLM is going to analyze that. So it's really helpful to go underneath and see this, because then you're like, well, now I know how the adversary is going to attack me. They're going to format something crazy, and they're going to trick my LLM to do the crazy thing, is the next step of this. But we're not crazy yet. So this is not the point of this workshop, like breaking the LLM application. That's like a different talk, but like this can happen. Okay, so here's an example of it in action. You have SERP API, which is the searching. They're scraping Google search results and then selling it back to people as a service. They got in trouble for this, but that's just the backstory of SERP API. We use it because it's free and it gets us Google search results. And then you get LLM, is the LLM math. So I need something to do calculator operations. So it used to be, right, the old days of LLMs, it would try and do the calculator operation by text completion. It would go horribly wrong. But now what it does is if you ask it to do a math operation, it's calling a calculator and it's calling LLM math if it's a LangChain app, because, why not? And then you create an agent and you say, who is Leonardo DiCaprio's girlfriend? What is her current age raised to the 0.43 power? And that's what you ask. And then it's like, oh, I know how to answer that. So this is what I've been tasked to do. I know the first action I have to fabricate is a search. I don't know who Leonardo DiCaprio's girlfriend is. So I search the SERP API for the name of Leonardo DiCaprio's girlfriend, and it comes back. The observation that comes back is Vittoria Soretti. And then the next thought, so if you give this back to the LLM is what's the next step, it's like, oh, find out Vittoria Soretti's age. So you do another search, like search for her age. And then that comes back with an observation, 25 years old. I need to calculate 25 to the raised to the 0.43 power is the next thought that the LLM generates. And then from that thought, it knows to generate the tool call calculator 25 to the 0.43 power. And then it's like, I know the answer. It gets the observation. It's like, I know the answer. Give it back to me. I'll just send it back to you. And that's how the chain actually works. Okay, any questions about this? Yeah.
Mention it every 10 times.
Mm-hmm. So right here, when it says the like it knows all of this, and then it realizes when it parses this, that this is the answer to that question. So the LLM has to be smart enough to link this to this observation and know that this is the right answer to send back the user. That's the magic of the LLM. Being told when you think you have the final answer, stop the loop, send it back. Okay, so this can go awry, and then you can get an infinite loop, which is why, like, all of my we were getting infinite loops a lot at the beginning. This is why my initial agent was like, put a cap on the number of tool calls to 8. Because otherwise, it's like, wipe out all your coupons because you accidentally kicked off an infinite loop in your agent. So you kind of don't want that. So, but mostly it'll fail fast. But I think there have been times when you had agents run away. Like PentestMCP will run away. We don't put a cap on. It'll try like, depending on the model. So if you have Opus, okay, maybe it won't run away. But I tried it with Gemini, and it tried like a gazillion different exploits in Metasploit, and none of them were the right one. And I'm like, Control C, and like, yeah. But your mileage may vary. It gives up after. Do you put a iteration limit on? No, it knows to give up. Oh, okay. Okay. So this is going to be interesting because the results you get, we don't know. We don't know what you're going to get. Well, hopefully it works, but we'll see. We'll get to that. Okay. So I'm going to give you an example. This is the build up to the first lab. This is an example of the SQL agent and how a SQL agent will work. So the idea is to automatically translate your user query to the actual SQL execution plan, so you don't have to learn SQL. I don't know how many of us are database people here, but it's like, this is not a language I want to learn. Most people don't want to learn SQL. So you're like, wow, natural language generation of SQL? Sign me up. So here's the scenario. You have a user, you have a database, you have a user, and you want a SQL, an agent that has SQL tools to be able to translate the natural language query into the actual database call, and get the result, and then send it back to me. So that's what we're going to do. So let's say you have implemented 3 tools for your agent to leverage. One is a database list tables. One is a list the schema for a table or a database. And one is an actual query. Run the SQL database query directly. This is kind of dangerous. And so this is your first lab. You're like, yeah, this shouldn't make you feel good to have this as a tool. And this is the problem. Like, if hopefully the person writing the agent in whatever organization you're at doesn't have this as a tool. Eventually, so this was actually in the mainline LangChain, this functionality. And then people complained, and then they were like, okay, we'll move it off to the experimental side. But they're like, yeah, and no, you don't want full-on access to your database that the user can prompt the agent to invoke, because there's no access control. And there's very little, even with, even modern times, there's very little access control on the tools themselves. And that's a big problem. Securing tools will be the #1 problem in generative application engineering, like for the next 5 years, I think. 5-10 years, it's like securing these damn tools, because the agent's gonna fall for it. So then I gotta like build something into the tool to restrict access. So that's my opinion, at least. Okay, so this is the thought. You're like, so the question is, how many customers do we have in our database? And you're gonna use these 3 tools to answer that. So it's like, okay, this seems to be a question for our database. When it comes to the databases, I know I have 3 actions. I have 3 tool calls. I gotta first start I have to know which table to query. So the first call is to the SQL database list tables. Where is the customer table? What is it called? So this is the first tool call. I gotta find the list of tables. And then the observation comes back. I have agents, customer, and orders. And I'm like, okay, I know the customer table. So the next query that the agent knows to do next is like, well, give me the schema of the customer table to see what columns I can use. Now, technically, if the agent were smart, maybe Claude would skip this step. Technically, if you know the customer, the name of the table, you could answer that query by just doing the SQL query and doing a count. But this is a slide example, and I didn't want to delete this. So it can make this next query. And the example is to show you how it uses all 3 tools. But the query that you gave, you only needed 2. It's like, okay, give me the schema of the customer table. What are the columns there? And then it comes back with this. It's like, oh, it's got like the customer code, the customer name. And then it's like, oh, I know I should query the customer table to get the number of customers in that table. And then it generates a raw SQL database query, select the count from customer. So it really didn't need this, but it asked it anyway. But that's what an agent does. The agent's doing a bunch of stuff that it doesn't necessarily need to do if it's if it's not a good reasoning agent. But yeah.
I was gonna ask, don't they use the reasoning to skip steps and be more efficient on their work?
Yeah, it depends on how it's been trained on the reasoning task. And you'll see actually, the training and the step-by-step thinking is super important. Otherwise, you're going to get awful results. So there is one exercise there where you're like, give me the password hash of the admin user, and it fabricates the column name, and then it breaks. It doesn't work. So this might be a safety check. It's like anytime you have a query that you're going to generate against a table, make sure you understand the schema of the table first, no matter what. That could be the training, the instruction training that the model has been given, and then do the query. And you'll see that there's going to be a query that says password hash for admin user. It's going to break because the agent didn't go and find the schema of the table first, because the column is pass hash. So it didn't know the name of it, and it just fabricated the name. And then what you needed to do is say, do this step first. So step-by-step thinking is basically what you have to do. So this is where prompting matters. You have to tell the LLM to do step-by-step thinking. You have to give it the steps if you know it. And then you get predictability. Because if you don't, the LLM is going to take shortcuts and give you garbage. Because the LLM is lazy, just like the rest of us. It's like, if I think I know how to answer your query, just going to give it to you. But if I give it the homework to think step-by-step, it actually will allocate more resources to answer your query than it would if you just told it to just do the task. This is where it matters. This is where the engineering matters. It's like, how can I get more work out of the LLM? Well, the way to do that is to actually give it incremental steps to do whatever it is you're asking it to do. So that's kind of like a side learning when I cover these topics. Okay. So then you do this select count star from customer, you get the result 25, and then the model's like, oh, now I know the answer. You got 25 customers, and I give it back to you. Okay, so the last kind of agent I want to talk about, we don't do this yet because the LLMs, well, maybe the LLMs are at this point now, are code agents. So why don't we just let the agent produce all the code? You're like, the agent produces the tool call, the agent produces the overall application, and then this is like vibe coding, complete vibe coding. That's what a code agent is doing. You just say what you want, and it goes and does this. So the reason why you want to do this is because it can be more effective to build your application in this architecture than to define tools and then have the LLM call it. And there are situations where this is better, and there are situations where the multi-step one is better with the tool calls. Okay, so here's a task. Determine the most cost-effective country to purchase a smartphone in: USA, Japan, Germany, or India. And so for each one of these countries, you're going to call, if you've given it the tool calling, you're like, I got a tool that basically converts currency. I have a tool that basically, oh, I don't have all of the, get the phone price in the country for a particular country, get the exchange rate, get the conversion and the taxing of that phone. And I'm going to call that for every single country. And this is 12 tool calls. So every time, 12 steps, every time I go back, I have to do an LLM call to produce the next step. And so you're like, well, you know, what if I just say, give me a program that does this, one tool call to generate the program, one tool call to execute this program that has all these calls built in, and then one call to the LLM to process the result. So this is where you would do a code agent. Now, this is okay for small functions, but like this is non-determinism 101. You're like, can I get this program to be written all the time the right way? And then what are the costs of doing this for things that don't necessarily need it? And that's what I teach this, but we don't do much code agent in my class. Okay, so that's agents. So LangChain was first to market, allowing you to build agents very quickly. And this is why we started with LangChain, because it was portable. It had the sort of the critical mass of developers developing on it. And so that's what it is. So it's like you have a large library, they have a large library of tools, and then they actually they implement all the different agent architectures. Someone publishes a new agent architecture in NeurIPS, and it's like sitting there, the LangChain engineer is sitting there showing you how it's built in LangChain. And then you just include it and you say, well, I'm going to do a plan and execute agent, and I'm going to see the results. So that's why you would use something like LangChain. It also has support for you to write your own custom tool. So if you have tools that are very specific to your organization, well, you want to be able to augment the tools that are in LangChain with your own. So that's another benefit of this development environment. And so the tools are typically written and bound to your application. So they are local to your application, and the code is calling out to the storage system, GitHub, Google Drive, Slack. There's like Slack tools that you can call. So this is where you're enabling your application with all of these different pieces of function. The problem here is that everybody is writing their own, and they might be duplicating the same kind of code. And the other problem is that once the API changes or is deprecated, everybody's got to change their individual applications. So this motivates the topic we're going to talk about next. This is why MCP was developed, and this is why it took off. And this is why, like LangChain, yeah, you're a $125 million unicorn, but maybe not for long, because I do think they're going to get undercut by MCP. At least their initial ideas were being undercut. So this was Anthropic from 2024, at the end of 2024. It's an open source approach for connecting models to tools, and it can be done over the network. And it's an interoperable protocol that just uses standard JSON RPC over HTTP or HTTPS to get back and forth over the network to implement the tool call. So this is an RPC to do your tool invocation. So rather than everything being local on your program, you can make an RPC call to get that tool, and then the LLM is still sort of, the inference is still running within your agent, but then you're going out and calling the MCP tool remotely potentially. So the analogy is that the browser or the web app is discovering and accessing services over HTTP and web APIs like REST APIs and Open API. The analogy is that MCP is doing the same thing for agents and the tools. It is the interoperability layer for agents to invoke tools. And this is why it took off. So, okay, and you can either run, so the tools could either be running remotely, or they could be, you could actually do this model where they're running on the same machine as well. So you could actually have you could go back to the LangChain model and have all your tools local if you just have it invoke it over standard IO. You're going to do all the patterns. You're going to do standard IO. You're going to do remote through a serverless function hosted on Cloud Run, just to see both styles of operation in your lab. Okay, so for those of you who know about REST APIs, so REST APIs, the way they got standardized and specified was through Swagger and OpenAPI. You specify what your API does and how to leverage all the functionality of the API. And then all the code for accessing that API can be automatically generated. That's what the benefit of Swagger and OpenAPI is. We're going to do the same thing for MCP. That's basically what MCP does. Standardized way for LLM agents to discover and interact with external tools and external data and external services over this protocol. It's doing the same kinds of operations. MCP is going to allow a tool to tell an agent, this is what I support. These are my tool calls. These are the function parameters and what their semantics are. And now the agent's like, okay, thank you. I know how to invoke you now. I know how to leverage all of that stuff to get what I want. So that's the idea. It's the same thing with OpenAPI. Here are my endpoints. Here are my parameters. This is how you call me. And then the client can produce the Python package to go and access that API sort of in a predictable way. So this is really allowing you a transition where before you were like, hey, I have all these rich APIs. I want my LLMs to be able to access and leverage. It used to be that you would have your LLM agent just figure out the OpenAPI spec, download the OpenAPI spec, and then figure out the API call internally, and then invoke the API call that will get me the result. And in fact, there is a toolkit in LangChain. It's called the OpenAPI toolkit that does just that. It's like, you give me the OpenAPI spec, I'll create a tool, and then you can invoke it. But what MCP has done is like, no, we're going to replace that. Now we're going to have the MCP server be, you could put your APIs in the backend here. You just have an MCP server with discrete function calls, tool calls, that will generate the API calls, and then you give your LLM agent access to that. And it's all these things are done the same way. This is what I have students do in my cloud class now. It's like I teach them all about APIs, but I got to teach them a little bit about LLMs now. And so like, yeah, have an MCP server talk to your APIs. And then you would have an agent be able to query an API. Like, what's the weather? And then the agent, they build a thing that interfaces with OpenMedio, and then they get the response of the weather. Okay. So one of the nice things about MCP servers is that when you do this, there's a lot of things that can go wrong. Some of these OpenAPI specs they're hundreds of pages. And LLMs are terrible when the context size starts to go big. They have much harder time reasoning about what to do. You gave it too many options, and it's going to choose poorly if you gave it too many options. So one of the nice things about MCP is it narrows what the LLM can do. What are the calls that you have available? And they're very targeted, and they're custom to your app. So this is really a way of getting more accurate behavior out of an LLM. So that's why you would want to re-architect things to make it a little bit more predictable. Okay, so this is what it looks like. Yeah, this is so this is like the plumbing of it. You might not be interested in this, but I teach them because it's like, I got to demystify this for you. It's basically, you have a client, you have MCP servers that will interface with any of your services that you want to have the agent invoke. And then, you can then have a natural language interface to that backend. So this is the protocol. You have a chatbot. This is your agent. And you're like, oh, I've been configured to point to a particular number of servers. I'm going to say, what tools do you support? Give me all your tools. And then it will send you a list of tools, including all the descriptions of how to invoke all of these tools so that the LLM knows how to formulate that JSON call, that JSON RPC call, to get what it needs out of the MCP server. So that's the first step. And then during the execution, if you are doing this React loop, and you're like, oh, I know a tool call that will get me to the next step, I will invoke this tool on this server using the arguments that I've been told to supply at the bootstrap at the start of it. So this is really important. The MCP server, whoever's writing that server code, has to be very precise about what it's describing as the tool call. So this is where prompt engineering matters. you have to tell you're teaching the LLM at runtime exactly how to invoke your tools. You better not cut any corners. You could actually ask it to think step by step. You should try and get more CPU inferencing out of it to get a more accurate call. And so there's also a benchmark for LLMs on tool calling accuracy. So they evaluate all these tool all of the ability of all of these LLMs to generate accurate tool calls. And you want, like if you are doing an agent, you want to pick a model that is at the top of the tool calling list, right? Because that's the whole thing your agent is doing. So yeah, you would want to go with, I think who's at the top? Opus is at the top of the tool calling you said yesterday. I don't track it, but like, yeah, apparently Opus. JSON, yeah. So it's good at JSON, which is basically tool calling as well. So any code generation thing, yeah, you're not gonna like. Nobody gets fired for buying IBM was the saying back in the day. Nobody's gonna get fired by using Claude Opus right now, I think, because that's basically where we're at right now. Okay, so there are a whole bunch of reference servers that are out there. So in like week 4 or 5 of my class, I'm like, yeah, just pick one. Go to this URL, and then, well, here's where malware, so this is a security problem. Some of these MCP servers here are not legit. And you're like, so I tell my students, I don't know if any of them do it, but I look at the code, make sure it's legit, make sure there's not obvious like backdoors or anything. I mean, they maybe send it through an LLM, say, is this particular code base, does it have any backdoors? Is it trying to execute shell commands? Do some vetting of the MCP server, because this is a huge list, and you have no idea who publishes these things. And so like you kind of like it. So Google and Slack, they do have blessed versions of these things. So then you use the blessed version versus someone else. But yeah, there's a bunch of malware out there posing as MCP servers. But
I think this was maintained by
it is, but there's opposite.
yeah, maybe if they're using Opus to detect malicious MCP servers before they put it up in this GitHub repository, that would be cool. Then I would tell them. Then I would give my the students could then just willy-nilly just install that. Yeah.
MCP servers, so yeah, always.
Okay.
Yeah, those are.
It's just a bunch of GitHub repositories. I contributed a link to our documentation a while ago. But if you submit just a GitHub link to it, and then after you submit it, you push your malicious code, you could theoretically.
Once you become a contributor,
And
that's the GitHub
and
problem,
then
right?
turn pro.
Yeah, I'm pretty sure they have a disclaimer.
Food for thought. Maybe someone could do a BSides talk next year talking about this and how, yeah, I don't know. Maybe you could vet all the code that is linked from this thing and say, well, how many people have employed this strategy to get on this GitHub and then go rogue? You could write an agent for that. Maybe we'll vibe code it. You got an hour after the talk? Okay, so this is the idea. You're like, yeah. So you're calling, hey, I have a question about my closed deal. So I go to the customer relationship management MCP server, which is what this HubSpot thing is. And then it'll fork it to that. And then it's a GitHub request, and it goes to the GitHub MCP server. And then the Slack goes to the Slack one. Okay, so that gets us finally, sorry about the length, that finally gets us to the SQLite MCP exercises. The first exercise is to willy-nilly deploy a terrible MCP server and to know that you should never do this ever again. But you hope that other people are also never going to deploy something that looks like this ever again. And this is only to get you to see the mechanics of writing your own MCP server and leveraging it from a client. And it's like basically 20 lines of code. So it's not like rocket science to build up one of these things. So this is the code. I have an MCP server that is basically natural language interface to this user database. So MetaCTF is a CTF we run at Portland State. And I have a user database that does the authentication. I want to ask questions about it. And so I have this MCP tool that says, query the database, give me a query string, and I'll produce a list that's the results of the query. And so these are my instructions. When I do a list tools to the MCP server, it's going to pass back the name of this function and the parameter and this description. And this has to be enough for the LLM to be able to formulate that JSON invocation accurately. Turns out this is actually not a very good description, but it fits in a slide. So that's why I put it here. But you'll see for this guy's MCP, PentestMCP tools, you go and look at that description, they're legit. Go look at those descriptions for what you should be doing. This is just because it fits on the slide. I don't want to inundate you with too much text, but just know that this is terrible. You're just going to take this query, you're going to get a cursor onto the database, and then you're just going to execute this thing, and then you're going to commit the results and then return it. Okay, so this insecure tool design is what I tell students will keep them employed for many years. Just auditing all of the tools and seeing that they can't be subverted is a useful job, like a 24/7 job, I would say. Well, maybe with the LLMs you can make it easier, but you have to do this kind of thing. Okay, and then this is the client. It's like, so this is why it's like I might as well introduce this to freshmen in college, because there's like not a ton of code here. I just teach them Python, and I just teach them a little databases, and then they can build their own agent, and they'll be like, oh wow, maybe I want to study computer science. So this is it. Yeah, so Fast Agent is a agent architecture that's specifically designed with MCP in mind. So this is why, like, you could use LangChain agents for this as well. LangChain has an MCP adapter, so you could do both the LangChain tools and MCP tools. But Fast Agent is basically MCP only. And so you're like, you're a SQL database tool, perform these queries, and then I call it vulnerable at least. So, so this, like, when they launch this server, at least it's named vulnerable SQLite server, and then basically that's what your lab is. What you're gonna do first of all is to figure out ground truth. Like, you want to make sure that the LLM can appropriately generate the SQL query to answer the questions that you give it. But in order to validate that, you have to actually see what's in the database. So the first part of the lab, and this is what I have my students do all the time, is establish ground truth. Like, you cannot develop confidence or reliance on an LLM tool unless you know and you have seen it produce accurate results over and over again. So what you're going to do is you're going to take SQLite 3 and you're going to poke into this database to find the answers to the queries that you're going to eventually give the agent. So that's the first step. So, and then these are the queries. So you're going to use SQLite 3 to get the answers to all of these 4 questions. And then you're going to ask the LLM, what are the column names for the users table? What are all the usernames that begin with the letter A? And then you're going to give it harder queries, and it's going to fail, hopefully. This is Gemini, so it will fail, probably. Find the admin user in the database and output the password hash. And this is where, if the LLM doesn't know to take the extra step to find the schema, it'll fabricate the column name and fail. And then what you do to fix this prompt, and this is what I want students to do, is to say, think step by step. And that's all you need to do. All you need to do to this to get it to actually produce an accurate result. Or you could also explicitly say, find the name of the column, the column name of the table that stores the password hash, and then find me the password hash of the admin user. So toy around with that, because that is the fundamental thing that we're trying to train students. We're like, how are you getting what you need out of the LLM? And that's what this third query kind of shows you. So there is some intent there. So students are like, hey, it doesn't work, it doesn't work, it doesn't work. And I'm like, well, this is the learning. This is what I'm trying to, yeah, of course, because they're not used to things not working that the instructor gives them. But this is an intentionally broken thing. And this looks like a simple thing. You're like, well, I thought LLMs were good. Not so much sometimes. And then you give it a more complex one, and you're like, password hash algorithm and the number of iterations that are being used to store the hashes in this database. And then your mileage will vary on this, but I give you the real large one that has all the step-by-step instructions, and it can do that. So again, this is an exercise of trying to be able to prompt the LLM appropriately and validating it against the results that you might get back. So this is that complex one. So you'll see that the LLM is better at this one down here. And you're like, holy heck, this is hard. This is much harder. And it fails on that thing. And you're like, oh, go figure. Okay. And then finally, because it's vulnerable, you'll do this. Drop the users table. And then they'll be like, oh, crap. I can't do the lab anymore. And then I show them how to do a git checkout to get the database back. But then you do the destructive queries, and the destructive queries will then take you to the next lab. It's like, I need to make a better tool so that when someone tells me to drop the users table, it's like, oh, sorry, I don't have the tool to do that. And I'll just say no. That's what you want. So you see this, you say, okay, now I get the problem. And then we have a secure one. And so there's a little bit of so I get actually incrementally give them the security fix. I'm like, okay, here's a better secure, a more secure database design. I'm going to only give you fetch users. And I'm going to say select username from users. So this is all the users. I'm going to let you list all the users, fine. And then I'm going to say fetch users password. Give me a user, fetch the password, select pass hash from users where username is equal to user, the parameter. And then that's my more secure. You can't do a drop tables on me anymore, or can you? This is SQL injection. So yeah, I tried. So it looks better. I actually have secure interfaces, but the tool itself, it's like it's still broken. So then you're like, okay, this is a better design pattern. Fetch users, and then look, I know parameter. I can parameterize query just like the best of them. So now it's a parameterized query. And then you're like, well, can you still drop the table? I give you $20 if you give me a query that drops this table because I can use it in my next class. But I don't know. I think this is secure. But
if you're using parameterized queries, I think it is.
Okay.
Unless it is doing something.
yeah, I should give this to Claude and say, is this really secure? And then maybe it'll give me an attack vector that I didn't know about.
There was someone that said, thought they found it, turned out the model hallucinated the entire time.
Yeah, so no hallucinations will get you $20, but I'll give you $20 if you actually get something I can actually add to this saying, yeah, you're not quite there. But all right, so that's the second one. And then the third one is to run this over HTTP. So there's a MCP server that's been deployed using this secure version on Cloud Run. So it's a serverless container. There's a Docker file. You deploy this, you just install the SQLite server, you run the you install the packages, you run the code, and then that deploys here. I think there is actually a version of this, so you don't have to do the deploy on this one. You just point your MCP agent to this URL endpoint, and then you'll be able to get the sort of the over the network MCP call. And this is what a lot of people are going towards. In fact, Google just announced they have like their MCP sort of platform, hosting platform. So you can put all your MCP servers on Cloud Run, on Google Cloud. And this is the most efficient way of doing this because it's like serverless. It's like it's going to only cost you if it's actually handling queries. So that's why I wanted to show people this, because if they're going for an interview and they don't want to fund a whole Google Cloud project to have something running 24/7, then all they need to do is put it up on Cloud Run. This will take you like maybe 25 cents a day, maybe? No, 11 cents a day. If you have a container running, a minimum container running so you can pin the number of containers that are running here. And like you kind of want at least one, otherwise that first startup is like 5 seconds. So yeah, if you do that, then it's like 11, 12 cents a day. At least it was last year. Okay. So finally, you get to do some hands-on stuff. Sorry for the long-windedness of this. SQLite MCP Code Lab, you go to this URL. There are 3 code labs there. Hopefully you've joined the Google group. Go to the Google Cloud Platform console and select the PentestMCP group. If you cannot find that group, let us know. We can try and debug. And then there are instructions there. You are launching your own Kali VM and running the SQL exercises locally on that Kali VM. Yeah. So all of this leads us to PentestMCP. So hopefully you have an understanding of agents, and you have an understanding of MCP. Now we're going to talk about PentestMCP. So the question PentestMCP is trying to answer is, how well can LLMs automate the workflow and the playbook of a penetration tester? So if you're a junior penetration tester, you're like given a playbook and you're like, yeah, in any engagement, just follow all of this stuff. And then you run all this stuff and you do some simple tasks and then you complete the engagement. But we're like, well, LLMs can do that too. You give it a list of instructions, it'll follow it. In fact, it loves a playbook and a list of instructions. And so that's what this next generation of script kiddies is doing. That is what they have access to, is like, what are the capabilities of this? And what does that mean for the rest of us who aren't doing this? So the approach is to build MCP servers for common tools that a penetration tester may utilize in that playbook, and then test agents that have these tools to see whether or not they can actually do a penetration test automatically. So that's, yeah.
Primary is the playbook being generated by AI. Well, so are you having like it create its own playbook?
You can. So you'll see, well, you have to give it some of the tools, but then it can generate its own plays. So this is what it's doing, actually. It's generating its own play. We're not giving it a playbook per se. So it's generating, but the playbook it generates is limited by the tools that we give it. You give it more powerful tools, it's going to generate some awesome plays. And that's what PentestMCP is. So we give them some really cool tools, the best tools, and then we'll see what can it do. So here are some of the tools in PentestMCP. We haven't tested all of these things, but we were like, well, what's the first step in an engagement? Well, you're going to do reconnaissance. You're going to do some OSINT. You're going to collect information. You're going to go to like Shodan. You might do a scanner. So that's more passive, the first one. But then you're like, oh, I have the Nmap. I can probe. Let me see where they're running stuff. What do I need to figure out in terms of their operating system, what vulnerabilities they might have running, or what network IP addresses have services on them. I might go and use curl. So if it's a website, maybe I'll just do some curling to enumerate all of the resources on the back end. And maybe I can find a vulnerable URL. Maybe I'll use GoBuster to do that enumeration. So GoBuster is a brute force directory scanner. It just uses common names of directories, and it just tries them all. And if you've done security through obscurity on your website, it's going to find those directories that you hid. And then you're like, maybe you find a target, and you're like, well, let me see if what they're running is vulnerable to something. So maybe you can query these services that you have found against the OpenCVE database. It's like, is there a vulnerability that's been known that can be exploited? I'll just check the database. Maybe I'll use Nuclei. This is a vulnerability scanner. It will automatically find and test all the services that it finds for the latest in vulnerabilities. And then maybe I'll do searchsploit. How do I exploit these things? I'll look it up. I have a CVE. The software, I'll look it up in searchsploit, see if there's something I can deliver that gets me a shell on this particular box. And then I want to exploit the thing. So maybe I'll use comics, which is a command injection sort of scanner, and then exploiter. So if it sees something that you're running that is vulnerable to command injection, it'll go get you a shell automatically. And you don't even have to type the injection. It'll just do it for you. Maybe you find a SQL injection vulnerability, and you want to dump the entire backend database of the thing that's vulnerable to it. So then that's what SQL map is really good at, and that's part of your toolkit. Maybe you want the whole 9 yards, so then it's Metasploit. Metasploit does the scanning, Metasploit does the vulnerability discovery, Metasploit's got a huge library of exploits, Metasploit will do the post-exploitation for you. It's got it all, so I'll just give you Metasploit to do all your tasks. So this is like what you would teach, like in some of these SANS courses. Yeah, you would learn Nmap, you would learn Metasploit, you would learn vulnerability scanners, you would type it all in, and you like pass the test. So like, can we get an agent to pass the test too? Maybe. If we are getting an agent to pass the test, should we be giving that test anymore to anybody? That's a problem. That's where like that industry is going to be changing very soon, I think. But that's just my conjecture. And then maybe after you've exploited it, maybe you're going to do some post-exploitation sort of pivoting to find other credentials, to escalate your privileges and do this sort of thing. So if you want to come across some password hashes, maybe you want to run Hashcat to sort of up your privilege levels and increase your access on the target. So that's what you'll be doing. This is the PentestMCP exercise. The idea is to write a generic agent for compromising a vulnerable server using common penetration testing tools. And so there's a lab that I run. I still run this in the Web and Cloud Security class that I teach. And it's like, you can go and click on that lab if you want. And what it is that it's the vulnerable Apache struts instance. I have this in a container. I deploy it, and then I ask students on their Kali VM to use Metasploit to compromise it, not automatically, manually. And then they're like, okay, I'm teaching them how to use Metasploit. And this is what it did. This is the walkthrough I give them. And you go to this lab, you're like, well, start up the Metasploit console. And then you're like, search for Apache strut. So they don't even have to do the vulnerability scan. I give them the vulnerability. But it turns out we're going to make it a little harder for the agent. Like, the agent's got to discover it. I mean, come on. And so we're like, okay, search for struts 2 because you know the thing is vulnerable. And then when you find an exploit that you want to use, you say, I want to use this particular exploit. This is a strut. So when you do this, it'll give you the sort of the vulnerabilities and their sort of the confidence level in terms of whether or not they'll work or not. And so you'll choose one. You say, this one's pretty reliable. And then what you'll do is just like, well, that's the exploitation. But usually when you exploit something, you want to attach a payload that will then sort of perform an operation to give you further access after the exploit. That's what a payload is. So then you're like, well, I'm going to search the payloads that can be attached to this exploit so I can get persistent access. And in this case, you'll see that one of the compatible payloads is reverse TCP, which will give you a shell. It'll give you a callback shell when you deliver it. And then what it needs is to set the parameters of the exploit and the payload to make that connection happen after the exploitation. So you're going to set the remote host. This is the target you're trying to exploit. This is the port that it's running on. So it's clear text HTTP. And then you're going to say, this is the URL that's vulnerable. So again, this is students are hard coding this. We're going to have the agent try and do this automatically. We don't want to tell the agent any of this stuff. And then you're going to be like, well, the callback. So this is your Kali VM. Once I deliver the exploit, I need that reverse TCP payload to call back to me. So then I'll set the callback, the local host, and this is your Kali VM. And you're like, we're going to use port 80 as well. And then we're going to have that be the communication channel. And then I type exploit, and then I get a shell back. And students are like, oh, wow, it's that easy. You know, I can be a hacker. And that's the point. So, okay. Shouldn't an agent be able to run this playbook is the question. And the answer is yes. So we're going to give it some good tools. You probably could do better tools if you had spent more than a week and a half building this, the tools would be better. But like, whatever, I had you for however many weeks I had you, and yeah, 4 weeks. And so it is what it is. Don't throw stones. This is the Nmap tool. We're like, okay, I'm going to teach you how to use the Nmap command to get what you want. And I give you some instructions, and I'm going to tell you, oh, please don't use this -p-. So this got added afterwards after he was like, dude, it's doing the worst. Yeah, so he has to prompt it. This is where prompt engineering matters. Like, there's a reason why the prompt is written this way. It's out of experience, yeah.
So even if you provide the port number, you still do dash?
Yeah, every model, every time, they're all like, even the reasoning ones are like, I want to scan everything.
Okay.
Yeah, but you see, you give it at least here, you give it the tool name, you give it the target address, and then you give it the options to the command. And then you say, this is how I want you to use that tool. And then this is just basically, I'll just invoke the tool. So I'm giving you access to Nmap with full access to the command. And then I'll do a little bit of security so that you can't inject me. But that's the tool. Okay, so Nmap. Now I can scan all your networks and find targets. So that's the first, the target discovery one. And then I'm going to do the vulnerability discovery. So this is what nuclei is. So I'm going to allow you to invoke nuclei, and you point nuclei to a target, and it runs all of the enumeration of all the different software versions in terms of what is running and then what it's vulnerable to. And it gives you a high fidelity signal. It's like, yeah, this one is vulnerable to struts too. So this is what we give it. And then, yeah, we'll just drop you down into nuclei, and you just get the results, and then you feed that back into your program to figure out what your next step is. So again, this is all agentic. So we tell it, let's see, returns the scan result as a string. So we're not even giving the agent an explanation of the results. You get much better performance on an agent if you can help it parse what the results actually mean. So we're not even giving it that, which is why some of these models are terrible at this function and some of them are way better. And then the real heavy lifting is the Metasploit. So there are a whole bunch of pieces of Metasploit that are useful for an agent to invoke. One of the first ones that you saw in that script was search. It's like, now I know Nuclei has told me there's struts 2 on here, and it might be vulnerable. So then I'll implement a search. And the way Zach implemented the Metasploit interface is through the RPC daemon. So Metasploit has the RPC daemon that will invoke Metasploit functionality in an RPC call. And then these tools will call into that in order to get the functionality out of Metasploit. So this is the first one. It's like, hey, I'm looking for struts 2 vulnerabilities. Search for a module, an exploit module, given that search term, and return me the results. And then the agent will see the results, and then we'll be like, I'm going to pick a particular one that I think will be useful in order to execute the plan that the user has given me. So the user has given me some instructions. I have figured out some things it's vulnerable to, figured out the exploits that are available, and I'm like, well, which of these exploits is going to get me to the next step of trying to compromise this machine? And then you will search particular modules. So let's say I chose one. Now I have to figure out how to use it. So it's like, okay, the LLM's like, okay, I want to use this module. Tell me how to use it. And so it's like, give me information about this exploit module. This is a WordPress admin shell upload. And then tell me how to use this thing. Okay, so that's the next step. And then finally, or the next piece of that, not finally, is like, okay, now I have the module information. Tell me what payloads I can attach to this exploit that can get me further into the path, like code execution or a shell. And so this is what you're going to do next. You're going to say, well, what module payloads does this particular exploit module, can I piggyback onto this exploit module? And that's what this next one is. What can I attach to this WordPress admin shell upload to get me functionality? Probably a shell. And that's this payload. And then give me information about this particular payload. Like if I select a payload, I also have to learn what that payload needs in terms of like configuration. So that's the next step of this. So maybe your reverse shell needs the IP address and the port number of where it needs to call back into, right? It needs a callback. So that has to be set as a parameter. And the payload info will tell you that. Will tell you you need to set these things up with this call. And then I can finally invoke the exploit. I'm going to say, use this exploit with this payload using these parameters, and then get me a shell. Well, most of the time we're getting a shell. So it's like, and then invoke it, exploit it, and give me back a shell. And that's what happens with this particular call. And then after I got my shell, I'm going to use Metasploit session. So the RPC daemon now has a shell. And now you as a client would be like, well, I want to interact with one of these shells. And in order to figure out the sessions that the MCP server or the RPC daemon has, you say, what sessions do you have? And it'll give you a list of integers, which are interactive shells on anything that's compromised. And then you say, okay, on this particular shell session ID, I want you to run a particular command. And so if you have asked the agent to exfiltrate the password file, then it'll be like, okay, I'm going to interact and say cat etc password, and then give it back to me. And that's what this thing, well, this says who am I? So figure out who you're running as, but like in your lab, hopefully it's going to cat etc password if you tell it to. And that's the idea. Should in theory, if we're lucky, if we've made our sacrifices to the computing and AI gods, it will work. Okay, so this is what it looks like. You bring up fast agent. It says it's connected to these 3 MCP servers, Nmap, Nuclei, and Metasploit. And then when you type /tools, it says, okay, this is the client, has access to the Nmap scan. So on the Nmap MCP server, there's a function Nmap scan, and you see the description there. This is what the LLM is using The agent is using this description to know when to call it. And then there's this nuclei scan. The agent is then understanding how to invoke nuclei. And then Metasploit search and the rest of them. And you see the descriptions that are in the comments. This is what the agent gets. And these are the agent's powers, superpowers, is these tools. Okay, so I edited this just so it would fit on the slide, but it's getting the whole thing. It's getting the whole 9 yards. Okay, and then the agent's super simple. This is the agent. You're a vulnerability discovery assistant. Your task is to discover them. And then these are the servers you have access to. Nmap, nuclei, and Metasploit interact. Okay, and so here is, yeah. 3 separate servers. This one has 7 tools because of those Metasploit RPC calls. So there are 7 tools in this one. There's 1 tool in that, and there's 1 tool in that.
2 separate servers is the way I've structured. So, for example, and not just like let's have it for example, for each service or like that server, everything on this their FTP server, so then all you can stuff, and then on another server, let's say typical time. The reason they're all separate is so you can build them. You don't want to build it one big one.
Yeah, you're going to confuse the heck out of an LLM if you give it an MCP server and tools that it doesn't need. So this is why you kind of separate them out. It's like, if you don't need the Nmap, actually, when you launch this thing, you get to select which MCP servers do I want to instantiate. And the best results are when you just give it the ones that it actually needs, which is these 3. So we do recommend when you're doing this, just select those 3. Otherwise, you do get this pollution effect. And so the way to organize the tools is like you're getting all the tools in the MCP server by default. And so in order to not get the tools, you have to just not select it. So this is actually done via questionnaire. This is not the actual code you're running. The code you're running is actually this is runtime generated based on what you, yeah. Yeah.
Give it everything once, and it used everything.
Yeah, so that definitely that questionnaire thing. I think I'm going to try and put more of that stuff in there, but questionnaire broke. It wasn't compatible with one of these versions of, what's it? Works on this guy's machine, but not on everyone else's. But yeah, the questionnaire thing where at runtime, you can enable the tools that you actually need is the best approach for running an agent, yeah. Okay, so we're going to give a query. It's like find security issues, and this is the vulnerable struts. 0.19 and attempt to exploit them to exfiltrate the password file on it. And then your IP address is .21, so you need to be able to configure the callback. And so the agent actually needs to know, in order to configure that correctly, both the target IP address and your own source IP address. Now, you could have asked it to do the scan, in which case, like, it would do the Nmap and find the target. But like, we're pressed for time. We don't want to let that Nmap go. We don't want a full scan for sure. So we're going to give you the IP address. Already it takes a while because nuclei just takes forever. But this is the execution loop. So we're going to trace the agent execution. What is going on in the thoughts of the agent and what tools is it calling? So the first thing, and this is GPT 4.1, which should still work. And so the first tool call, well, I'm going to do an Nmap scan, and I'm going to scan the target. This is what anybody would start with. And then give it these options. And it's no dash p dash, because we told it not to. And it followed our orders. And then we're doing an Nmap scan, and this is the result you'll get. It's not human readable, but it's machine readable, and the machine goes and it looks. So it's kind of truncated here. There's 998 closed ports out of 1,000 because it found like the 2 ports, the SSH port and the web port. I was like, okay, there's 2 ports. Those are the 2 ports I'm going to check. And I'm going to call the nuclei vulnerability scanner. And then this is the target. And I guess like, if it were smart, it could actually just give it the 2 ports, like it'd do 2 calls, but I don't know. Okay. Okay, so then that's a nuclei issue, but like, yeah, it's gonna actually do the whole thing, which is fine. And if you look at this, it finds, look, there's this CVE here that's critical, and this is the pathway. It's a redirect that goes to the showcase URL. So it's like, oh yeah, it's great. It tells me what the vulnerability is. It gives me the path. And then I was like, well, that's clearly struts 2. Now I'm going to ask Metasploit to search for struts 2. This is the exact same thing as the first step in the manual sort of playbook that I showed you earlier. And it does search for struts 2, and it looks, oh yeah, here is a struts 2 plugin showcase organal code exploit, which is the one that we want. I kind of edited this to put that snippet in there. This is way longer than this. But then it looks at that output. It's like, okay, I'm going to try this organal code thing. And then it's like, I need to find out information about this exploit. So I am going to do a Metasploit info on the struts2 organal code to see what kind of payloads I can send to that thing. That's what this is. And it gives you like some information about the exploit. It's remote code execution, which is really helpful when you want a cat Etsy password. So you're like, yeah, that looks good. Well, maybe I'll use that thing. And you can see the tool calls here. So this is truncated, but these are the individual tool calls that are supported that the agent has access to. And so you can see them highlighted here as we go along. Okay, so then it's like, well, tell me about this module, this exploit module. What payloads does it support? I need to figure out everything that I can attach to this so I can choose the thing that I want to actually do the deed. And then in this case, it comes back. It's like, oh, yeah, you could do a reverse TCP on it. You could send an interpreter shell. You do all these things. And then the agent. So this is, again, the agent is coming up with this playbook. The agent's like, OK, well, what do I do with this? And the agent decides, in this case, what is it doing? Oh, wait, sorry. It's trying to figure out the module payloads and how to call it. So that's basically this one. And then the agent decides to do the exploit. So in this case, it delivers the exploit, and then it attaches the payload that it wants, which is the reverse TCP, but it forgot to do something. It actually forgot to set the options of the payload to actually give it the callback. So if you look at this input validation, so it called a tool, and the tool came back saying, you forgot to set the module options to give me the IP addresses of the callback. And you're like, oh, you know what this is? This is bad, like not bad. This is incomplete tool descriptions. You didn't tell the agent that this particular tool has a mandatory need for options to be set. And so the tool didn't tell the agent to set this, so the agent didn't know. And the agent tried to send the exploit without the module options set appropriately. So this is an example. So this doesn't exist anymore. You can't get this error because this is where tool descriptions matter. So this was after a week and a half, this error happened, and we're like, oh yeah, that's on us. We didn't say, set the options, but I kept this for posterity because it's a good teaching thing. Yeah, you have to tell it to set the options before you set it. Yeah, before it does it.
Could you also manipulate this one through the prompt itself, force it on the model to do that, but they may still decide you have a probability that they may not.
You could encode it in the prompt. So yeah. So it can't discern between what was in the prompt and what is from the tool after, because they're all in the same context. But it has to go somewhere. You might be able to. You could try this. You could actually. No, you can't because it's in the tool description for sure. Yeah, but you could twiddle with that. You could remove it from the tool description, put it in the prompt, and then see if you can get this error again. But yeah, the tool descriptions really matter. Okay, so then here's the key. It got this error, and it was like, oh, well, let me just set the tool, the options. Like, I know how to fix that error. So it's like it's automatically on the fly getting that error and knowing, oh, you told me to set the options. Let me set the options. You don't have to do anything. It's just a wasted round. So you basically wasted an LLM call. And that's what it does. And it's like, okay, I am going to call the exploit with the option set, the R port and the L port and all that stuff correctly. And lo and behold, I get this shell on the end of this thing. Okay, so then I'm like, let me interact with that shell. And if you look at the last thing, it's like, okay, I just want a cat Etsy password because you told me to, and then you get Etsy password, and then it comes back to you. Okay, so that's the exercise. That's the URL. You have to bring up your own vulnerable strut server. On your Kali VM, you have to bring up the Metasploit RPC daemon. And then, yeah, run the agent, get the password file. Hopefully it works. And then we're not going to have time to choose your own, but like if you want to do the rest of the third code lab, that's all there. All of these vulnerable servers, and then you can point the tools and the agents to them, and then just run those on your own. Yeah. Okay. I'm not going to go through this, but I'm going to say thanks for attending, and then we'll be here until the end of the workshop, helping you get PentestMCP running. All right.
If you hit type on errors, cover it.